All right, as we prepare for the test that you have this week on Unit 9, today we're going to be working on the classwork for Algebra 2 here, Unit 9 review. As usual, we'll do some problems together. We'll pause the video so that you can try your own. So it says, for number 1, in the year 2020, the enrollment at a school is 3,000 students. Enrollment is declining, all right, so obviously that means it's a decay, at an annual rate of 1.125%. So first, it says write an expression that calculates what the population will be after X years. Now remember, because this is going to be an exponential decay, we're going to be using the formula that says y is equal to a times 1 minus r and then t. Well, we already know that the initial population is 300 or 3,000. We also know that the rate is 1.25, but when we move the decimal over, yes, we're going to need the 0.125, and you have to leave everything the way it is for now. And they said instead of calling it t, they want us to call it x. So I'm about ready. The question asked to write an expression, not to solve it yet. So my answer is y equals, the a is 3,000, 1 minus 0.0125 to the power of t. Now, in here it says, all right, well, now they want us to calculate the population, what the population is going to be in the year 2030. So that means they want me to use this equation. And you know what? We could actually shorten this equation up, as we should, especially if we're going to use a calculator. It says 1 minus this value. So with a calculator, I can find out that becomes 0.9875 to the power of x. I almost forgot they didn't want a t, they wanted an x. So this would probably be a better way of writing the answer for letter A. And of course, now we know that if they're going to go to 2030, I'm not going to put 2030 up here. Remember, this kind of experiment that they're looking at started in 2020. By the year 2030, my time frame is now 10 years later. That's what we're plugging in up there. So to find my answer, I'm going to get my calculator ready. Now that it's shortened up like this, 9875, and then to the power of 10. And so just like that, we let the calculator take over. Now remember, we will be getting a decimal value for this. So let's show you here. So it's 3,000, 0.9875 to the power of 10. Now, this is the answer I'm getting on my calculator. But remember, we're talking about students. So we can't do decimals really. So it's 2645 or 2646. But because it's just the 4, we're going 2645. So 2,645 students. Now remember, that just means they said the population of the school was declining, enrollment was, so that's why it's less than the 3,000 that we started with. Now, moving on to number 2. Number 2 is yet another one of these. This is from section 9.1, if you remember. So remember, use your word wall. Use your notes right now to get ready for this test. And it says, you deposit in an account that earns 3.2 annual interest. Find the balance after 7 years when the interest is compounded monthly. Now, if we do it a month, well, just think how many months are in a year. So my n will be 12. Now, we already know what our principal balance is. The principal amount that we started with was 1,000. I know my rate, they gave me a rate here. Now, they wrote it as 3.2, but remember, we write that as 0.032. We never use that actual percentage, turn it into a decimal, even if a decimal already exists there. So 0.032. And then, of course, we also need a time. And the time frame they gave me is 7 years. So put 7 right there. And now we have everything we need. Now, they said compounded monthly. So that's why I know that I'm going to be using the formula that says A is equal to P, 1 plus R divided by N to the power of NT. And I have everything. They said they want the balance. So if they want the balance, then that's 1,000. 1 plus, and then the R is 0.032 the n is 12, and then it's 12 times 7. And then we very carefully type that in to our calculator, and we find out. Now, remember, we're talking money here. And they said, what's the balance? So we want to know what the bank account is going to say when I log in and see what it is 7 years later. And that dollar amount, according to the calculator, is $1,250.70. That's how much is in the account at that time. But then it says, well, how much interest does the account earn after the 7 years? Well, remember, I already know how much my bank account is showing. This is the balance. But when they ask you about earning, that just means one thing. All I have to do is take what the bank account says and subtract what I initially started the account with. And so once I do that, I now know that it earned or it made $250.70 on top of what I had already started with. So remember, there are two different types of questions. If they ask for the balance, that's what the bank account says is in there. If they ask how much you earned, how much did it earn, then that's when you do a little subtraction just to find out how much extra it had made on its own. All right. And finally, on this page, before the you try problems, it says you deposit $1,000 in an account that earns 4.12%. Now remember, we're going with 0.412. And yes, I use that whole thing. Annual interest compounded continuously. All right. Now that one had its own formula for it. When it said continuously, that's when we use the formula that says A is equal to P E to the power of RT. So they said, find me the balance after 6 years. Hey, balance. Remember, I want to know what the account says when I log in to check it out. So here we go. Let's see. I do have an initial amount, which was 1,000. My rate is 0.0412. And then I needed a time frame. Well, my time frame was 6 years. So I'm ready. Throw this in here. Let's see. My P is 1,000. E to the 0.0412 times 6. And then we very carefully let the calculator, we type it in, right? Very carefully on Desmos. And we get a dollar amount of $1,280.44. So this is what the bank account will show. When I log in 6 years later, that's how much money will be in there. But if you notice, look at the next question. How much interest does the account earn? As soon as they say earn, not balance, this is the subtraction one. That means I have to take the 1280.44 that my account is showing and subtract what I started with, the initial amount, my principal amount. And so in this case, we just found out that the amount of money it actually made was $280.44. So remember, there is a difference between tell me what the balance or the amount is versus how much did it earn. All right. So we're going to pause this video for a moment so that you can try numbers 4, 5, and 6 on this packet. And let's see how you do with those. All right. Give it a try. All right. So now let's continue on with number 7 here. You will have to do 2 graphs on your test, and it's all by hand. You don't do those parts online. The first few questions will be online. The last page of your test is always on paper. Just keep that in mind, because some people have accidentally left it blank because they forgot there was that part. So, anyways, the questions you're going to be doing on paper have to do with graphing. So here we go. It says graph y is equal to 2e to the negative x. Now, just remember, as soon as we see that it has a power of x, we know that this is a parent function. The parent function would be this, e to the x. That would be the parent function. The fact that it's a negative just means that in this case, for an exponential function, it actually means decay. So when I draw this curve, this is why it's good to know this, we better see it landing, right? It's like it's coming down for landing. So that's what we're going to be looking for a problem like this. And let's just make a quick table because that's how we drew anything with an exponential function. It's tough to do these just at the top of your head there, right? You need to work these out. All right. So as we start to create this table, remember, when it's an exponential base e, we go straight to a table. It's really one of the only ways to do these. We're going to plug in a -1, a 0, and a 1. So remember, when we're plugging into this equation, on Desmos, I would type in 2e, and then I would put a parentheses with a negative, and then a spot, an empty spot for the number that we're going to be plugging in over and over and over and over. So the reason I bring this up is, remember, the first number I'm going to plug in is a -1. So technically, it's a positive one if you think about it. All right, so let's see. 2 e to the power of negative, and then I can say -1. Notice how we throw in that extra parentheses for that negative. All right, and I get 5.436. So 5.4. All right, and then I do this again, but now I'm going to do this, of course. There's the negative power there. Oh, too much of a parentheses there. Power of 0 this time, but remember, anything to a power of 0 is pretty much the same thing. So I get to put a 0 in there. And so we just get a 2. Remember, a power of 0 means it turns everything into a 1. 1 times 2 is 2. Oh, sorry, it's a 2 here. All right, and finally, our last one is we're going to go 2e to the negative, and then I'm going to plug in a 1. So this time it is a -1 in this case. All right, so here we go again, but I'm typing in a 1 this time. See, very much like Desmos there. All right, and my answer is 0.735. So 0.7 is fine. And now I have every number I need. So remember these, just a little careful. -1, and then 5.4, so somewhere right around there. 0.2, 0.7, so 1 and 0.7, so that's up here. Doesn't get quite to the 1. Remember, of course, they did not move this up or down. And if they did not move this up or down, then my asymptote remains in the same location, the original one. And so here's my graph. It kind of drops down. Remember, like if it's landing and it gets closer and closer and closer and closer, never quite getting there, but very, very close to it at that point. It does say describe the transformation. The only thing we had here as a transformation, remember, was the number 2 in the front. And so when we have a 2 in the front, that just means that this is a vertical stretch by 2, because that's what we were multiplying all of these values here by 2 here. So nothing else besides that. And then it says state the y-intercept. When I look at the graph, very easy to see that it's the y-intercept is the point 0, 2. And just like that, there's my y-intercept. And the asymptote was still the line y equals 0, the original x-axis. Now, I'm going to do number 9 here since it's just here on the side and we can still see it very easily on the screen. It says graph y is equal to 2, which, by the way, that again is a vertical stretch. A vertical stretch by 2. We also have a -1 right here. And so when I have a -1 at the power, I'm going to think opposite. So I'm actually going to go to the right one. And the -3 here, which is not part of the power, means that we are going to head down 3 spaces. So there's a lot of moves here. In fact, I can already answer this question right here. It says describe the transformation. So it is a vertical stretch by 2. And then we're going to translate right 1 and down 3. All right. Now remember, this is an exponential function. So when I do draw it, keep in mind that the asymptote that is normally here, just like I drew it here, because we're heading down 3, that asymptote is actually going to move. So I can actually already answer this question because I wrote down 3. We already know that the asymptote for an exponential function will be y is equal to -3, because we are going to move everything down 3 spaces, including the asymptote. So that's why it's good to kind of break it down in advance. And so now we're going to go with some 2 basic points, right? So I'm going to start off here. There's my y. So there's my x. There's my y. Remember, these are the two classic points that all exponentials go through. I'm going to go with 0 and 1, but this is the one I'm going to test. Y is equal to 2 to the 4/3 x. Not with the -1, not with the -3, this one. I'm kind of using this as a parent with a stretch at the same time. So when we say y is 2 to the, and then 4/3 to the power of 0, well, anything to the power of 0 is 0, which means, sorry, anything to the power of 0 is 1. So 2 times 1 is just 2. There you go. And then, of course, the other one says y is equal to 2 4/3 to the power of 1. Well, the power of 1 doesn't do anything. It's just 2 times 4/3, which in this case would be 8/3. Now, 8/3 is kind of tough to draw, but that's why with a calculator, we would understand that the y is about 2.6 or 2.7 is what we're looking at here. And so here are my 2 points. These are for the parent function, or a parent with a little bit, of course, of a stretch. 2.7 here. All right. Oh, and I almost forgot. Because this is bigger, this is going to be growth. We should see it taking off. All right. So here we go. 0, 2, and then 1, and then 2.7. Now remember, this is the parent function. I haven't started moving anything. So something like that. But now remember, everything is moving down 3 spaces and to the right 1 space. So the first thing I'm going to do is I'm going to draw my brand new asymptote right here. And now I'm going to move everything right 1, down 3. Right 1, 1, 2, 3. Right 1, 1, 2, 3. Remember, look how close they were before. They still should be that close. And so here comes our graph. See, taking off just like we said it would in the beginning. Now, the only issue here is it does say, tell me what the y-intercept is. It's hard to tell what the new y-intercept is. I didn't draw an actual point on there. So we can easily find it, of course. And anytime you find a y-intercept, all you have to do is make your x equal to 0. So 4/3, 0 minus 1 minus 3. And of course, we work this thing out. Let the calculator take over, of course, okay? All right, so let's see what we get. 2, and then it's 2 parentheses 4 divided by 3 to the power of -1. Number 0 minus 1. And then it's minus 3. So I get negative 1.5 as my answer. And so that right there is my y-intercept. Or, of course, we can write it down as a point, 0, comma, negative 1.5. Just like that, there's our solution. All right, so that brings us to one more on this page where we're going to be graphing now what we call a log. And this is the kind of log that you're going to graph on the test itself. So when you're doing a log, you're working with a log. Remember, there are 2 basic points that they all go through, but the first thing we want to do is this. We want to break it down. And when you see an x minus 3, yes, it's in parentheses, so that means left and right. That also means you have to think opposite. So that means we're going to go to the right, in this case, 3 spaces. The only other thing, of course, is when you are talking about logs, remember, logs have vertical asymptotes, right? They have these walls that you just can't go through. But when you move something to the right, remember, that means that you are also moving that asymptote, because this time it's a vertical line. So when I describe it and I say translate right 3, that means the asymptote, right? If I'm moving to the right, not up or down, that affects exponentials like you saw earlier. When you're moving to the right, the asymptote is now going to be x equals 3 is what we're looking at for these. Okay. So let's talk about the parent function. The parent function is y is equal to log base 5 of x. And we said every parent function, remember, you don't bring in that minus 3. There's 2 points we're going to talk about. And the parent function that all that all log functions go through is 1, 0. This is what all parent functions go through. So they're going to go through this point right here. And whatever the base is with a 1. Well, my base is a 5. So the point is 5, 1. So it's going to go through 5, 1. And yes, this is going to be kind of like growth. But notice how it makes that very sharp turn, because it can't go up really quickly because it has to touch that point there. And now this is where we get to move everything to the right 3 spaces. So here we go. Here comes the brand new asymptote right at the number 3. There's the asymptote. And now everything's going to move to the right 3 spaces. So remember, even this little point right here is going to move 3 spaces over. 1, 2, 3, 1, 2, 3. There they are. These are the new points. This is the new asymptote that we're going to be getting closer and closer to. And then it just kind of makes that turn right there. And it keeps climbing very slowly, but it continues to climb. Now, they do ask for one last thing at the bottom. They said state the x-intercept. We kind of got lucky that we see the actual x-intercept right at the number 4. So then the x-intercept is the point 4, 0, because remember, in an x-intercept, the y value is always 0. All right, so with that said, you're going to do the next page, all of page 3. There's only 3 questions, so you saw 3 graphs right now. You get to practice 3 of your own. So let's take a moment to do that. Oh, and don't forget to check your answers with the key. All right, so now that you've had a chance to work on those problems there, I believe it was numbers 10, 11, and 12. So you should have worked on 10, 11, and 12. So now, back to it here. Let's do these problems together. Now, these are some of the easier questions you're going to get on the test. It says to rewrite it. You're not solving. You're going to rewrite it in exponential form, which means here comes the circle method. So it's d to the power of t is equal to the x. And then just like that, we're already done. Same thing on this one. We're going to be rewriting in log form, which means we start at the base, go to the other side of the equals, and then we come back to the exponent. So we get a log base 2, that's where I started. Next thing is 16. I just keep following the circle. And it equals the 4. Remember, the answer to a log is a power. That's why the 4 ends up out here. All right, moving right along. Like I said, these are they're going to be some of the shorter, easier questions on the test. It says, well, what is the inverse of y equals log base 12 of x minus 2? Well, first things first, when they say inverse, that y is now an x. Everything else remains, but that x is now a y. And now it's our goal to get that y out of there, because that's how we're going to find the inverse. Remember, the only way to get rid of a log is to go exponential. So I start at the base. So here comes that circle method. Go to the other side of the equals. And then we come back to what was left. In this case, the y minus 2. So we have 12 to the power of x is equal to y minus 2. There's that circle method, just like you did on top, right? All we did was rewrite. So now the only thing left for me to do to get the y by itself is get the 2 out of here. Now, don't forget, you cannot actually add these 2 numbers together. This one has a power of x, so the way you read it is the way you write it. It says 12 to the power of x plus 2, then put a plus 2, and just like that, there's our answer. So once again, these are some of the quicker problems that you're going to have on the test so that you can take your time with those solving and, of course, with the problems where you graph. Now, last 2 questions before we take a little pause in the video. It says use the one-to-one property of exponentials to solve for x. Now remember, these are exponential functions, so no need to check my answers afterwards. But the problem is they don't have a matching base. Now, there's not much I can do with the 2. The 2, I'm stuck with it. And then over here, in order for this rule to work, this also has to say a 2. Now, the thing is, in order for me to use a base of 2, and I'm going to try to get a number 8 out of it, 2 times 2 is 4, times 2 is 8. So 2 to the third is going to give me that 8. But don't forget, it already had its own extra power of 4x minus 2. And so there, it's ready. My bases match. In fact, I can even take a little moment here and do a little distribution. So 2x minus 1, 2 to the power of 12x minus 6. The bases finally match, which means my powers are going to be equal to each other. So now let's work with the powers. And when I'm looking at my powers, I have more room over here. 2x minus 1 is equal to 12x minus 6. Get rid of the 2x. Negative 1 is equal to 10x minus 6. Let's add the 6 to the other side. 5 is equal to 10x. And we divide by 10. And x is equal to a half. And so just like that, remember, this is an exponential. Really no need to check because we don't have any domain issues. So just like that, we have our answer to this problem. You have to make the bases match. But that's why if you already know this is a 2, then for this one, you just go 2 times 2 times 2 times 2, however many times you need to make sure you get to that 8. I bring that up because here you have a 64. You're going to have to ask yourself, right? There's a 4 here. 4 times 4 times 4, as many times as you need so that the bases match. And finally, for number 17. Now, number 17, it is a log, so I will have to check my answers afterwards. But this one says log base 7. That one says log base 7. Well, that can only happen if this x minus 3 is equal to the negative 2x plus 9. Then that's it. That's my setup. I make them equal to each other. And then I start solving. I add my 2x to both sides. 3x minus 3 is equal to 9. Add the 3 to both sides now. 3x is equal to 12. And when I divide by 3 on both sides, we get that x is equal to 4. And before I say, yes, this is an answer, we're going to double check. Remember, the only thing I'm concerned about is that I take a log of a negative. That's what I don't want to do. So here comes our quick check, and that's why you have Desmos to help you. Log base 7 of 4 minus 3. Yeah, that's going to be a positive number in there. 4 minus 3 is positive, so it checks out. But there is this other one, and that one already had a negative. Let's see what happens there. Negative 2 times 4 plus 9. So that would be negative 8 plus 9. That is definitely another positive number, and that's all we really care about. 2 positives, we're good to go. All right, take another moment there. Shouldn't take you too long for these, but you should be trying numbers 18 through 22 on this page. Just follow along with what we did here. This is how we prepare and get ready for this week's test. All right, give it a try. All right, and on to the last page here. Now, your real test has 16 questions total. So this has a little bit of extra practice. That's why you've been doing too many of these. But again, it's basically half of what you just saw. So you're getting one of each question on this review. So now this one says solve, round to the nearest 10th. It is an exponential. So because it's an exponential, there's no need to double check the answer. But remember, I can't go log with it or anything yet until I subtract the 3 from both sides. 7 to the power of x is equal to 55. And now I can go log with it. So here comes that circle method. Remember, logs are the only way for me to bring down a power. So it says log base 7 of 55, there's part of that circle, is equal to the power, which is x. And so now it's ready, but now we have a little bit of an issue. It does say to round it. Our calculators can't handle that. So then we get to rewrite it. It's going to say x is equal to log of 55. Notice how it's a base 10 now over the log of 7. Now on the test, this might actually be your answer already. But here they did say they wanted a decimal for it. So let's find out what that is. So I'm going to go with log of 55 divided by log of 7. And my answer is 2.0593, but they said rounded to the nearest tenth. So it's either 2.0 or 2.1. Because it's a 5, we're going with 2.1. All right. And again, it was an exponential function. Didn't really need to check that answer. Now, for number 2, it says we have a log base 3 of we have a quadratic here is equal to 2. Well, I can't solve for x because it's stuck inside the log. Well, then I'm going to go exponential with it. So here comes that exponential function. And it says 3x, 3 to the power of 2 is equal to x squared minus 4x plus 4. 3 squared is 9 is equal to x squared minus 4x plus 4. Let's get rid of that 9 now. So we'll send it to the other side because we do want a 0 when we have a quadratic. So x squared minus 4x minus 5. And of course, this is when we factor 1 times negative 5 is negative 5. The negative 4 below. Well, then the only numbers that work are negative 5 and positive 1. They multiply to give me a negative 5, but they combine to give me a negative 4. So those are our factors here, x minus 5, x plus 1. We're going to set each one of these equal to 0 now. Low on space there. But when I set them equal to 0, I know that when I solve, I'm going to get x equals 5. And when I solve this one, I'm going to get x equals negative 1. But now we have to check our answers, and this is where the Desmos calculator comes in handy. Log base 3 of, all right, here, look, we got to plug it into this. 5 squared minus 4 times 5 plus 4. And again, we don't care if it equals 2 or not. We just want to make sure this is not a negative value. That's it. So that would be log base 3 of, and then this is where you let the calculator take over. All right, let's see. So 5 squared minus 4 times 5. What was it? Plus 4. All right, I got a positive 9. And yeah, it's a positive 9. Remember, that's what matters. So this one checks out. I'm going to be using x equals 5. That is part of my solution. Now, for the other one, I need to change them into negative 1s. So I'm going to go back in here. And let's see, I'm going to delete that. And I'm going to insert a negative 1. Delete that. I'm going to insert a negative 1. Okay, I also got a positive 9 when I plugged in a negative 1. So log base 3 of negative 1 squared minus 4 times negative 1 plus 4 was a positive. So they both check out. Then they are both officially the answer. Now, just be careful. You might get an extraneous solution. This one worked out, so we were okay. All right. So yes, some factoring is going to come in on the test in the form of a log. Then there's this one. I can work with log base 10 of 2, log base 10 of 5. 2 and 5 are the only values I can work with. And my goal is to turn it into a 50 somehow. Well, think about it. Log of 50. Well, to get a 50, all it could do is go 2 times 25. That gives me 50, but I'm not allowed to use 25. I can keep the 2, but not the 25. So then that would be the log of 2 plus, no, what am I talking about here? Times 5 to the power of 2. There you go. 5 squared is 25. And then the 2 here, now because they're multiplying, remember that means I get to bring in addition. So this is going to be the log of 2 plus the log of 5 squared. But one of the rules says that you are allowed to bring the power down in front, right? We have the power rule. And so we have the log of 2 plus 2 log of 5. And let's see, log of 2 is 0.301 plus, there's the 2, and then the log of 5 is 0.699. All right, we're just going to match this up. There it is. This is the one that perfectly matches what we wrote right here. So remember, the idea is we got to manipulate the number to turn it into a 50, and then we can apply the properties as we go along. All right. So speaking of the properties, it says condense the following logarithmic equation or expression. Remember, when you're condensing, I see a log, I see a log, I see a log. At the end of the problem, I should only see the log once. But in order for me to do that, I shouldn't have any numbers out in front. So that means the 2, here comes that power rule. I'm going to send it back up. So now this becomes the log of x plus the log of y squared, right? We got it back up there, minus the log of z. And so now I'm ready. All of these logs are now just going to be one giant log, we'll say. And here we go. There's an x. Then I write my x. It says plus, so that means times. There's a y squared, so x times y squared. A minus sign means that whatever's after the minus, which is the z, should be at the bottom of a fraction. Well, then put a fraction, and there goes that z. Just like that, there's our condensed form of this equation. So remember, just take it in order. As you read it, you start writing x times y squared. A minus means whatever's after the minus, just that part goes underneath the fraction. And so for our last problem, before you attack these last few you do questions, it says, is the following logarithm statement, is it true? Well, let's find out. So it says log base 16 of 4 is equal to 2. Well, there's only one way to find out. Let's turn it into an exponential. So it says 16 to the power of 2 is equal to 4. Well, think about it. 16 times 16, you can use a calculator if you need to. 16 to the power 2 is actually 256. So, this is a false statement, right? This power, 16 to the power 2, is not a 4. So, no, that is a definite false statement. But look how quickly we checked it. Just rewrite it. That's what we do. All right, with that said, everybody, get ready for this test. You will be ready for it, whether you're taking it on Thursday or Friday. You have a big ideas assignment to help you out as well with that test. So let's not fall behind. Let's get these assignments in and be ready for the test. Have a wonderful day, everybody.